Hi, this is Richard C. I'm a math tutor at Wyzant, and I'm answering a question submitted by a student having to do with this function square root of t squared minus 4. So this is he's seeing this in a calculus class, and so he's automatically, naturally the tendency is to use calculus to solve the problem, and it might even be part of a large problem set where calculus is required. This particular problem, though, is very straightforward and doesn't require calculus, but all you have to do really is draw the graph, and you can see immediately what's going on. So I'm just going to take that direct approach now, and we'll see what happens. So let's start. So y here is equal to square root of t squared minus 4. And there's an implied positive here with the square root. If you wanted a negative, you'd put a negative. If you wanted a positive and a negative, you'd put a plus minus in front here. There's nothing in front here, so this is the positive square root of t squared minus 4. Now it helps to remember that the square root function looks like this. You could see this is y equals square root of x. Again, positive square root of x. And you can see that this has a restricted domain. X has to be greater than or equal to 0. And we can just generalize that now and say anything under this radical has to be greater than or equal to 0. So you would just say, okay, t squared minus 4 has to be greater than or equal to 0, which means that t squared has to be greater than or equal to 4. And if you think about that solution, this implies that you have a graph that's here and here at 2 and negative 2, and the graph is going to look like this. It's just going to look like a square root function graph, and it's going to be symmetric, and it's undefined here. You see here the domain is that x has to be greater than or equal to 0, because you can't take the square root of anything greater than or equal to 0. And the same thing is true here. We can't take the square root of anything that's negative. It has to be 0 or positive. And so you just write this inequality, and then you think about this. The solution here is that t itself has to be less than or equal to negative 2, or t has to be greater than or equal to positive 2. And that's the solution. But it's better to think of it graphically. And so you can see on the left-hand side of the domain, the function is decreasing, so you would just say decreasing from negative infinity to negative 2. And notice it's going to be a square bracket around the negative 2, because negative 2 is valid, because if t is negative 2, then the square root is 0. And the function is going to be increasing from positive 2 to infinity for the same reason. Now, if you were to try to use calculus and take the derivative, you're going to get in a lot of trouble if you don't understand this graph, if you don't have this graph in mind. I mean, the derivative is only defined where the domain is defined. So you can't just take something like this and find the first derivative of it and figure, oh, I've got something that I can work with. That's not the case. And this is going to be true in general. You can't just, sort of take the first derivative first thing you do without even considering the function that you're working on. So it's just a good habit, I think, to understand, what the underlying function is, what the domain and range are, whether there are asymptotes and all sorts of things, because those are problems for calculus operations or any other kind of operation on a function. So that's all you need to do here for this problem. I think you're overthinking it because you've probably had about 20 problems where you had to take a derivative and look and find where the first derivative is positive or negative or zero and so on. And you thought, oh, this is the same thing. And it is kind of the same thing, but you have to consider the underlying function. So that's it for this one. And I'll see you guys next time. Bye-bye.